lecture. So today we are going to talk about statistical properties of images. Okay, so here we are going to cover important properties of images like profile, histogram, mean, and standard deviation. And after that, we will be going for various basics related to images like distances, different methods for distance calculations, and connectivity of pixels. Okay. So under image properties, let us start with what do you mean by profile. So as the name indicates, profile gives you details over certain duration. So for digital images, there are two types of profiles, row profile and column profile. So what do you mean by row profile? Row profile is row profile of an image is the plot of column number versus intensity of the pixel. So basically, it gives you detailed information of one particular row of an image. Similarly, column profile is nothing but plot of row number versus intensity of the pixels in that particular column. So this is very simple. What is profile? Then what is histogram? So histogram of a digital image is a discrete function. It is given by HRU is equal to NU. Now here, what is RU? RU is the youth gray level in the given image, and NU is the number of pixels in the image having gray level RU. Okay, so your HRU represents histogram of the image. So and normalized histogram is given by HRU is equal to NU divided by N, where N is total number of pixels. So when we normalize the histogram can take, HRU can take value between 0 to 1 when we normalize it, because we are dividing number of pixels belonging to particular gray value. We are dividing it by total number of pixels. Okay. So here U represents particular gray level, and it can take values from 0 to L minus 1, where capital L is nothing but 2 raised to N, and N or 2 raised to K, and K represents total number of bits used to represent each pixel. Okay, so if we consider 8 bits per pixel, 2 raised to 8 gives you 256, and U, that is gray level of a pixel, can range from 0 to 255. L minus 1, that is 256 minus 1, that is 255. Okay, so histogram basically gives you how many number of pixels are there belonging to every intensity level or gray level in the given image. Getting this? So let us talk more about profile and histogram in terms of numerical examples. So say you have an image as shown here. So this is an image of size 4 by 4. There are 4 rows and 4 columns. And say this gray scale for the given image is between 0 to 9. Okay. So say for the given image, minimum intensity value is 0 and maximum intensity value is 9. Okay. Now, if we want to plot profile of the given image for the second row. Okay. So for profile on x-axis, you should have number of columns, because if you look at the definition of row profile, it is plot of column number versus intensity value. Okay. So for row profile, here you should have column numbers. Okay. Now in the given image, there are only 4 columns. So here you should have numbers 0, 1, 2, 3, and 4. There are only 4 columns. Okay. And on x-axis, you have to plot amplitude of each pixel or gray value of each pixel. So here, if we want to plot profile of second row, we have to select this particular row, second row from the image, and we have to plot it here on this particular graph. This is simple meaning of profile. So here, this is your second row highlighted here, 4, 2, 4, 3. So on x-axis, you have column number. So this is your first column, second column, third column, and fourth column. And for first column, second row, pixel value is 4. So here we are getting one straight line, or we are getting amplitude value as 4 for very first column. For second column, gray value is 2. So this is your gray value corresponding to second column. This is third column, and this is fourth column. Okay, so if your image size is 1024 by 1024, what is the last number on this x-axis? If image size is 1024 by 1024, what is last number on this x-axis? Please type your answer. If image size is 1024 by 1024. Yes, Sharon. Last number is 1024, 1024th column. Okay. So this is about row profile. Now just answer one question. Say if I have an image with chessboard pattern, say there are black and white squares, then how the profile of any row will look like? Can you describe that profile? Please type your answer. If I have an image with chessboard pattern, how the profile will look like? Sharon, your answer is correct. I want answer from other students. Okay. How the profile of a row will look like for a chessboard pattern? For any row, how will it look like? Okay, so basically, if it is a chessboard pattern, we get first, yes, Sakshi, your answer is correct. So we get first few pixels as level high, next few pixels as level low, if that particular row starts with a white box, okay? Otherwise, it is exactly opposite. The row which starts with black box, first few pixels will be uh, first few pixels will take low level, then high level, again low level, then high level. So basically it will take square wave pattern. Okay. Profile will look like as a square wave for a chessboard pattern image. Okay. Now let us see how we can plot column profile. So consider now second column and try to plot the profile for this particular second column. Now for column profile, your x-axis indicates row number. Row 1, row 2, row 3, row 4. Okay. So on x-axis, you have row numbers, and y-axis will indicate amplitude of pixels from this particular second column. Okay. So this is your second column, and this is column profile for the given 4 by 4 image. So here there are 4 columns. So you have first, second, third, fourth row number. There are 4 rows. So here you have 4 numbers, and corresponding to each row number, we have particular pixel amplitude. So first pixel value is 3, then 2, 2, and last is 4. So this is very simple concept. Hope it is clear to all. Okay. So now let us consider one example to understand what is meaning of histogram. Okay. So again, we are considering same image with uh, size 4 by 4. And here we are assuming that there are gray scales in the range. Pixels are taking various values between 0 to 9. So minimum intensity level is 0 and maximum intensity value is 9. Okay. So for histogram on x-axis, we have to consider these gray values. So total there will be 10 gray values ranging from 0 to 9. And on y-axis, we have to plot number of pixels belonging to each gray value. Okay. So let us start with number 0. So how many pixels are there in the given image belonging to level 0? Please type your answers in the chat box. Belonging to pixel 0, gray value 0, how many pixels are there? Yes, Shravan, there are 0 pixels. Yes, Vikrant. Now, yes, Akshat, Manas, all of you have given me correct answers. Okay. Now, same is the case for gray value 1. For gray value 1, there are no pixels belonging to level 1. Then for next level is 2. For 2, how many pixels are there? 1, 2, 3, 4, 5, and 6. Yes, Shravan, your answer is correct. There are six pixels. Similarly, compute number of pixels belonging to each gray level and type your answer in the chat box. Okay. So basically determining the histogram means we have to count number of pixels belonging to each gray level in the image. So in the given image, there are 10 gray levels and we have to determine number of pixels belonging to each gray level. So I request you to write your answer. So first is 0, for 1 it is 0, for 2 number of pixels is 6. Similarly, determine number of pixels for 3, 4, 5, 6, 7, 8 and last gray value that is 9. Okay, I'm getting few answers. I'm giving time for all to compute these number of pixels belonging to each gray level. I want answers from other students, those who are not answering. Only few students are responding to my questions. Sakshi, your answer is correct. Yes, Aryan, your answer is correct. Okay, so everyone has completed it for 3. So for gray level 3, there are 5 pixels. Now give me answer for other pixels, 4 and 5 and 6 and 7. Yes, your answers are correct. Sharon, yes, Aryan, your answers are correct. So it is simply counting the pixels for each and every gray value in the image. So the histogram will look like this. So for gray value 3, there are 5 pixels. For 4, there are 4 pixels. For 5, there is 1 pixel. And for rest all 6 to 9 pixel values are 0. Okay. Count is 0. Okay, so this is nothing but histogram of the image. And instead of this matrix form, we can also represent the histogram on a graph. So when we plot it on a graph, this histogram will look as shown here. Okay, so there are no pixels belonging to gray value 0, 1, as well as 6, 7, 8, and 9. For 2, total there are 6 pixels. For 3, there are 5 pixels, 1, 2, 3, 4, and 5. For 4, there are 1, 2, 3, and 4 pixels. And for level 5, there is only 1 pixel. Okay, so this is histogram of an image. Now answer my question. Say again, I have same image, say 4x4 image with grayscales 0 to 9. Okay, and say my half of the image is white, means this half portion is taking 0 values and this half portion is taking highest intensity value, that is it is full white. Okay, so if I have this first two half of the portion at 0 and half of the portion as 9. In this case, what is the histogram? Please type your answer. For this question, half of the portion is white and half of the portion is black. So how the histogram will look like? Total, the minimum intensity value is 0, maximum intensity value is 9. It is given in the example. Okay. Yes, Soumya, your answer is correct. Any other answer? Only one student has given correct answer. What about others? No, Manas, your answer is not very accurate. Your concept is correct. Soumya, your answer is wrong. Whatever previous answer you have given, that is correct. Okay, so if I have half portion at 0, say first half at 0, first two columns, and rest two columns as 9, actually 50% pixels will take 0 value, 50% pixels will take 0 value, and 50% pixels will take value as 9. So in the histogram, you will observe only two peaks. You will observe only two peaks as shown here, and amplitude of the peak will be 8 for peak at 0. So at 0, you will get a line with amplitude as 8, because out of 16, 8 pixels will take 0 value, and next peak will be available here at pixel 9. And again, it has same amplitude, which is 8. Getting this? So you will get one peak at 0, other peak at 9, and both of them will take same amplitude. And this, in this case, this amplitude value is 8. Okay. And these intermediate peaks won't appear. Okay. Is it clear? So this is nothing but histogram. Now, instead of say your first column takes 0 value, second column takes value 3, third column takes value 4, and fourth column takes value 5. Okay, say 1, 2, whatever. First column takes minimum value, say 0. Then all pixels from second column, they take value 2. Then next column, all pixels are having value 3. And last column is having value 4. Again, you will have equal pixels belonging to each gray shade. And you will get here, for all the gray levels, you will get same peak value. For if all these are 0, there will be 4 pixels belonging to level 0. If we say all pixels from second column are 2, there will be 4 pixels belonging to value 2. For 3, again, there will be 4 pixels, because we have assumed all the pixels in third column are taking value 3. And for last column, all the pixels are having value 4. So again, there will be 4 pixels taking value 4. So again, you will get 4 peaks in the histogram with equal amplitude, 4, 4, 4, 4, right? And now for this image with these assumptions, if you consider a row profile, how will it look like? How the row profile will look like? Histogram will take equal peaks peaks of equal amplitudes, right? And if I say plot profile for this image, which is taking value 0 for first column, 2 for second column, 3 for third column, and 4 for fourth column. So for row profile, you will have here column numbers. Okay, column number, say first, second, third, and fourth. Now for first pixel, value is 1. For second pixel, amplitude is 2. For third, it is 3. For fourth, it is 4. So it will look something like staircase. Okay. If we consider continuous graph, profile will look like as a staircase for this particular image. Is it clear? Difference between profile and histogram. If we are considering histogram with same value in the columns, same pixel value for all the columns, we will get equal peaks. Histogram, shall I draw that histogram again here for this example? If all pixels in first column are 0, then 2, then 3, and then 4, then for 0 level, you will get amplitude as 4. Even for first level, there are total 4 pixels. For second, there are total 4 pixels. And even for the intensity level, sorry, this is if this won't be there for one. For others, you are getting same peak values. For third, there are 4 pixels. For fourth, there are 4 pixels. Okay. So you will get 4 peaks which are of equal height if we are assuming that all the pixels in one column are taking same value. There will be 4 pixels belonging to each gray level. Okay. Is it clear? Please write yes or no. Okay. So I think concept of histogram and profile is clear to you. Now in this example, again, consider one more variation. Say you have this 1/4 portion at 0, this 1/4 portion at 0, and this 1/4 portion as 9, and this 1/4 portion as 9. Again, even for this case, you will get a histogram with only 2 peaks. One peak at 0 and one peak at 9, right? So basically, histogram gives you an idea about image in a broader sense, but different images can have identical histogram. This is important. So histogram don't give you complete information, but it gives you an idea about the given image in a broader sense. Basically, it gives you an idea about contrast of the image. We will study this in more detail in next unit. Okay. At this stage, simply try to understand the concept of determining profile and histogram of the given image. Okay. Okay, so this is one more example of histogram. Say if there is an image, and if we consider a line which is passing through this bright spot, if we consider a line which is passing through this bright spot, and if we plot profile for this particular image, profile will look something like this. This is an example of profile. So if you observe here, there are very bright shades. Then that bright shade is slowly becoming darker. So profile is dropping towards black. at this particular column, it becomes exactly 0 pixel value, and that 0 value is maintained for next few columns. So here for next few columns, profile value is 0. Then there is a very bright spot. So this is indicated here by a sudden transition, because a pixel value is switching from black to white. Again, there are few black pixels that is indicated here. Then across this slant line, there are brighter shades than black shade. So this portion here, you can observe you are getting a sudden transition corresponding to bright shades from this line. Again, there are black shades, and after completion of this black pixel, there is sudden transition from black to white, and rest all pixels are white. So there is sudden transition from black to white, and rest all pixels are white. So this is one example of profile for a row which is passing through this particular bright spot. Okay. And this is an example of natural image. Okay. So here on for all the digital images that we are using, digital monochrome images, we are using 8 bits per pixel. So your x-axis for histogram varies from 0 to 255, and y-axis represents number of pixels belonging to each gray shade in the given image. So this is an example of any general image. Okay. Now let us have a look at what do you mean by mean and standard deviation. So I think you are familiar with these terms, mean and standard deviation. So mean of an image is nothing but average value of all the pixels. So we need to take summation of all the pixel values or all the pixels intensity values, and divide that addition by total number of pixels. That gives you mean or average value of the image, arithmetic mean value or average value of the image. And what is standard deviation? Standard deviation is as given here. Basically, every we subtract mean value from every pixel value, and then we take square of this difference. And we determine the square of difference for all the pixels in the image, and then we divide it by total number of pixels. So if we consider an image with size m by n, m rows and n columns, then the equation is as shown here. First summation n first summation n varies from 0 to n. For second summation, small m varies from 0 to m. It is slightly shifted here. That's why please correct this. And so these are the two summations, and we are considering this terms, square of the difference over all rows and all columns. Okay. So we take this addition and divide it by total number of pixels, which is given by n into m. Okay. So again, consider the same image. Okay. So determine arithmetic mean for this image. This is simple example. Add all these pixel values and divide it by total number of pixels. So there are 4 rows, 4 columns. So total 16 pixels are there. So please determine the arithmetic mean for this image and type your answer in the chat box. Arithmetic mean or average pixel value for the given image. I'm waiting for your answer. Please type your answer in the chat box. So simply you have to do 2 plus 3 plus 3 plus 2 till last pixel value divided by 16. It will give you mean value of the image. Yes, Manas, your answer is correct. Others, please give answer to this question. This is very simple question. Averaging of all the given pixel values. Yes, Sharon, your answer is correct. Vikrant, your answer is correct. Okay, now I'm getting many answers. Okay, so let us move to next slide. Okay, so mean is nothing but addition of all pixel values divided by total number of pixel. It is 3. Now determine standard deviation for the given image. So for standard deviation, we have to, for standard deviation, we have to determine uh, square of difference with respect to mean. So your first pixel is 2, 2 minus 3, because mean value is 3, 2 minus 3 and take square of that. Similarly, 3 minus 3, take square of that and add all these squares of differences and divide total addition by total number of pixels. That will give you standard deviation. So please compute the standard deviation for the given image and type your answer in the chat box. Okay. Okay, so please compute the standard deviation and type your answer in the chat box. Standard deviation is nothing but addition of square of differences of each pixel value in the image with respect to mean value. So this is equation for standard deviation. Now in our example, mean value is 3. So compute these differences for each and every pixel in the image and type your answer.